You are looking at Linux right now. The server that sent you this video runs it. Your phone almost certainly runs it. Android is Linux. Every one of the world's 500 fastest supercomputers runs it. The cars, the TVs, the routers, and the rockets that reach orbit run it too. One system runs all of it. Most people have never seen its face. Linux is a kernel. The kernel is the layer between your programs and the hardware. Your app never touches the CPU, the disk, or the network directly. It asks the kernel does the work. Linus Torvalds wrote the first version in 1991 in Helsinki. He was 21. Today the kernel is more than 30 million lines of code. Over 15,000 people have contributed to it. Start at the very beginning. You press power. The hardware runs its own software first. It is called firmware. On older machines it is the BIOS. On new ones it is UEFI. The firmware sits on a chip on the motherboard, not on your disk. First it runs the post, the power on self-test. The post checks the memory, the CPU, and the drives are alive before anything else starts. Now the firmware looks for something on the disk that can start an operating system. Where it looks depends on how the disk is labeled. The old scheme is the MBR. It sits in the first sector and caps a disk at 2 terabytes. The modern scheme is GPT. It removes that limit, and UEFI expects it. Either way, the firmware finds one small program and runs it, the bootloader. On Linux, the bootloader is almost always GRUB. It has 3 jobs in order. Find the kernel on the disk. Copy the kernel into memory. Hand control to the kernel and step aside. An older loader called lilo did the same job for years. GRUB replaced it. The kernel ships as one compressed file in /boot. The first thing it does is unpack itself into memory. Then it probes the hardware, CPU, memory, disks, keyboard. It loads the drivers it needs to talk to them. Now it needs the real file system, and it hits a wall. To read your disk, the kernel needs the disk's driver. That driver is a file that sits on the disk it cannot read yet. The fix ships right next to the kernel. It is called the initramfs. The initramfs is a tiny file system loaded straight into memory. It carries just enough drivers to reach the real disk. The kernel mounts it first, uses it to find the true root, then switches across. The real file system sits on your disk. The disk is cut into partitions. One partition holds the root. That partition is formatted with a file system, usually ext4. ext4 is the map. It records where every file's bytes physically sit on the drive. The kernel mounts that partition as the root of one single tree. The tree starts at a single slash. Every folder hangs under it. Linux lays that tree out the same way on every distribution. The standard is the file system hierarchy standard. /bin holds the core commands, ls, cd, and mount. /etc holds configuration as plain text files, networking, users, services. /home holds each user's own files. /var holds data that changes fast. Log sit in /var/log. /user holds most installed programs. The name means Unix system resources. Learn the tree once, and you can find your way on any Linux on Earth. 2 folders in that tree are never on the disk. /proc and /sys. The kernel builds them in memory in real time as it runs. Read a file in /proc, and the kernel answers on the spot with its current state. /sys exposes the hardware, and the kernel's own controls the same way. They exist because the kernel is running. Power off, and they are gone. The last thing the kernel does is start one program. It is called systemd. Systemd is the first process and the parent of every other process on the machine. The shape of all of this is older than Linux. It comes from Unix, written at Bell Labs in 1969. Ken Thompson and Dennis Ritchie built it. Unix set the rules that Linux still follows. Linux is a free recreation of Unix written from scratch. Unix carried one strong opinion about design. Write small tools. Each one does a single job well. Every tool reads text and writes text. You join them with a pipe. The output of one becomes the input of the next. ls lists files. grep filters lines, sort orders them, wc counts them. Chain 4 tiny programs, and you have built a 5th. The strength comes from how they connect. That design needs one more rule to reach everywhere. On Linux, almost everything is presented as a file. Your disk is a file. Your keyboard is a file. Your sound card is a file. A running program shows up as a folder of files. A network connection is a file. Open, read, write, close. The same 4 actions work on all of them. Learn one interface, and you can drive the whole machine. Watch what a program actually is. On the disk, it is one file, a list of instructions sitting still. Load it into memory and run it, and it becomes a process. The kernel gives that process its own private block of memory. One process cannot reach into another's memory. A crash in one leaves the rest running. This is why a browser can put every tab in its own process. And every one of those processes appears as a folder under /proc. Every file carries an owner and a set of permissions. Read, write, and execute set for the owner, the group, and everyone else. Chmod 755 lets the owner do everything and lets others only read and run. One account stands above the rules. It is called root. Its user ID is 0. Root can touch every file on the machine. Regular users are walled off from each other's data. This is how one computer safely holds 1,000 accounts. Windows takes another path. There, a device is an object reached through a special call. A process is a handle the system manages for you. The workings sit behind that wall. On Linux, the same workings sit in front of you as files you can open. That is why one tiny tool can touch anything on the system. The kernel is not one frozen block. It loads code while it runs. Each piece is a module. Plug in a new webcam, and the kernel loads its driver on the spot. The machine keeps running the whole time. Thousands of modules exist for hardware, file systems, and protocols. You load the ones you need and leave the rest out. The same kernel fits a smartwatch and a rack of servers. On Linux, the settings are plain text files you own, and most of them sit in /etc. Your shell, your network, your services, all written in files you can read. You can swap the desktop. You can swap systemd for another starter. You can shrink the whole system down to a few megabytes. Every line of the system that runs your machine is open to read. The kernel can also pretend to be many machines. A feature called KVM turns Linux into a hypervisor. One physical server splits into dozens of virtual ones. Each virtual machine believes it owns a real CPU and real memory. None of them can see the others. This is the engine under the cloud. The servers you rent by the hour are Linux dividing itself. The network stack sits inside the kernel. A connection is a socket, and a socket is a file. The same open, read, write, close you already know. The kernel handles the packets, the routing, and the retries. IP shows your addresses. SS shows your active connections. Every request in this video crossed a Linux socket to reach you. Now the scale. Android is built on the Linux kernel. That is around 3 billion active devices. Close to 70% of the phones on Earth. About 90% of the public cloud runs on Linux. Around 96% of the top million web servers run it. SpaceX flies Linux on Falcon 9 and on Dragon. Every supercomputer on the top 500 list runs it. One kernel from a wristwatch to a rocket. Linux is free, and its source is open. Anyone can read it, change it, and ship it. Governments and companies are moving to it to own their own stack. When the whole system is open, no single company holds the keys. It is a kernel, a tree of files, and one rule applied everywhere. It runs the phone in your hand and the servers behind the screen. Now you know its name.